Hi, and thanks again for joining me on Sealed for Good. And we are talking today about underground walls. It's a big one, retaining walls, such a big piece of the industry. Obviously, foundations and how we start from the ground up is the critical piece. Obviously, in construction, if you get that wrong, the rest of the building is buggered. So we've got to make sure that we get this piece right. And there are many, many methods and things that come up in the way of waterproofing these areas that are often brought our way. These are constant challenges we hear around the industry, regardless of what product or brand you're using. So I'm going to spend some time today talking about external retaining walls, but the positive side, okay, on the external side of it, not internal. There is a positive and a negative side of walls, which many of you would understand. We're going to be talking about how we treat those areas externally on the positive side and getting it right from the start. Now, many of the challenges and costs that end up happening if you get these wrong. So the positive side of a wall is our recommended method of how you always attack a retaining wall. Now, that may differ with the types of walls, but if you only treat it from the inside, the negative piece, what happens is you actually are masking the problems, you're hiding it, you're not actually getting it to the root of the cause or stopping the root of the problem. Because from the positive side, doing it that way, you stop the entry of water into the surface, into the substrate, and that is very, very critical, particularly in residential applications. There's different types of retaining walls or underground walls. So you've got your standalone retaining wall or a garden wall. You've got basement walls, which are big ones. Cellars, obviously, in domestic dwellings, which are very, very popular. And you've got your underground car park walls. Now, with the various types of retaining walls, there can be different ways that you need to approach the waterproofing method. The risk of a failed membrane in an underground wall can be catastrophic. So you've got obviously the repairs of internal wall floor finishes. That is the big one. So if you've got a membrane or a detail that hasn't been done properly on that positive face, once moisture enters into the building, you've got internal wall linings, internal wall finishes that are affected, and also floor finishes, and we've seen that quite commonly. So very, very important to get that piece right. If you have to repair a wall that's gone wrong, and any of those builders out there that are watching, I'm sure this might be bringing back some nightmares at the moment, but to excavate earth and soil to repair a failed membrane or a wall that hasn't been waterproofed correctly is a massive job and a massive cost. You know, you can treat it from the inside as a remedial piece, but it's never the same. And the problem you've got to understand is that particularly if you've got things like a block wall construction or clay brick in residential, once that water's into those surfaces, even though you might be masking it on the inside by attacking the problem from the inside, the issue you have is that you end up with the surface is always absorbing water. And once that's in there, you can't actually see the extent of the problem where that spreads, and it's not healthy for the structure. So doing it on the positive side is the way to go. So you have the issues that, you know, if the positive side hasn't been done correctly, then you've got the internal dampness that comes into the building. And again, in residential applications, there are health issues with that because you've got mold, you've got mildew, you've got a constant damp environment. Not good for people living in those areas that are going to be subjected to that. You've got damage that can be caused into the concrete if it's a concrete structure. Things like concrete cancer start. You have spalling concrete, you have salt damp, you have efflorescence. And obviously the other big one is the major delay to construction, very, very big, and delaying the handover stage. So what are the challenges of treating underground walls? This is where a lot of the applicators come back to us asking. They might have a system they know they want to use, but the question is then, how do I confront the conditions I'm exposed to? So the big one is, and I know a lot of applicators I talk to mention this frequently, is the limited space workspace. And this is very confined areas. Sometimes I've seen guys working in areas that are less than a metre away from the wall. You need to take into account all your risks involved in that, guys, because it is not a good environment to be in. You need to make sure it's completely safe and access points are clear. But maximising wall spaces are things now in design that's always there because we're trying to optimise the living space in buildings. So properties are constructed very close to boundaries. That reduces the access in there, trenches are reduced, and this also impacts the way you detail the wall floor footing or that junction, and that's a critical piece which we'll come back to later when we talk about application time. And as we know, the wall floor junction is where all the water falls in an underground area. You've got your major head of pressure at that piece, and that's where the entry of water comes in. So very, very important that you are aware that if you've got limited access, you need to be able to get down even further below and to the point where you can get to that junction between the footing and that first course of